Students, so I, Vikas come here to present to you the next session of ray optics. In today's session, we are going to talk about mirrors. In the previous session, we started with the basics of ray optics. We talked about two phenomena, reflection and refraction. Okay, and we saw that what all we have to cover in this chapter, and we saw the basics of reflection, the laws of reflection, and today we start with mirrors. So let's get started, everyone. So we are going to talk about mirrors today. Okay, and we are going to talk about plane mirrors today. Okay, so let me write that also. So we are going to talk about plane mirrors. Okay, now in the previous session we talked about a reflection of one ray. So we saw questions such as that if this is a mirror and let's say this is another mirror which is making 90 degree with the previous mirror, and suppose a ray of light is coming and striking one of the mirror like this, then how this ray is going to move, what will be with the deviation. So these are the things that we discussed in the previous session, right? Hi ISKCON community, hi Shah Abdullah Ahmad, good evening and welcome to the session, guys. Okay, so these are the things that we discussed in the previous session. Okay, just a minute, the chats are not completely visible to me, so we'll address that. Just give me a moment. Oh, it's not happening. Yeah, now the chats are completely visible to me. Okay, hi Chandradeep Yadav, good evening. Okay, so we talked about how this ray would move. So it will suffer reflection here, it will again suffer reflection here, and then we talked about the deviation of these rays. That was done in the previous session. Okay, now today we are going to talk about image formation. So our today's agenda is going to be image formation by plane mirrors. Okay, so this is what we are going to talk about, image formation by plane mirrors. Okay, now when we say image, do you recall that what was we were supposed to talk about? So image is intersection point of reflected ray. Do you remember this? This is intersection point of reflected rays. When we talk about reflection, it is intersection point of reflected rays. When we talk about refraction, it becomes the intersection point of refracted rays. Right now, because we are discussing mirror, it has to be the intersection point of the reflected rays. Now guys, if we are talking about the intersection point, to locate an intersection point, what do you think is the minimum number of rays that we need? Okay, think about this. If I want to talk about intersection, then what is the minimum number of rays that we need? Can you tell me, guys? Shahdeep, Chandradeep, Shah Abdullah, Chandradeep, what is the minimum number of rays that we will need? So if you are about to answer 2, then you are right. You know, I can't have a point of intersection with one ray. You know, for intersection to happen, at least 2 things should meet. Okay, so minimum rays we are going to need is 2. So what we will do, we will try to work with the minimum number of rays, and we'll then see that why it was okay to work with the minimum number of rays. So we want to talk about image formation. Okay, so what is the situation now? So let's say we have a mirror. Okay, let's say this is a plane mirror like this. This is a plane mirror like this, and what we did, let us assume that we kept a tiny bulb in front of it, you know, a tiny source of light. Okay, consider this as a very small teeny tiny bulb, okay, which will give out rays in all directions. So this ray is giving out light in this direction, you know, directly towards the mirror, maybe at some angle, maybe at some different angle. So it is giving out rays in all direction. Okay, it is giving out rays in all direction. Now we have to talk about the rays which are going to get reflected from the mirror. Okay, so let us pick any 2 rays. So Chandradeep Yadav, your answer is not correct actually. If we want to talk about intersection, 2 is the minimum number that we need. So out of these infinite rays that are coming out of the point object, okay, or you can say a point source of light, let us choose any 2. Okay, any two. So if I want to talk about any 2 rays, if I have to trace the 2 rays, I would want to choose the most convenient one. What do you think, guys? You will not deliberately choose the more difficult one. So one of the rays that I think is very, very convenient to choose is the one which is moving directly towards the mirror, because it will strike at an angle of incidence of 0 degree, and then it will just start retracing itself. It will start going back on the same path from where it came. So to draw the reflected ray, let me use green color. Okay, so one of the reflected ray that we get would be this. One of the reflected ray that we are going to get would be this. Okay, now I have to talk about at least one more reflected ray. So I will first choose any one other incident ray. Okay, so let me choose this one. So this is striking the mirror, and now I want to know where this ray will go after reflection. So what are the usual rules to do that? The usual rules dictate that we first draw a normal at this point. So let's say this is the normal at this point. We then identify how much is this angle. Right now I don't know how much this angle is, but let's just say that this angle is, let's say, alpha. Okay, so this ray will move at an angle alpha. Okay, this ray will move at an angle alpha, and I'm drawing reflected rays in green color. So I will draw something like this. So these are the 2 reflected rays. So I said that we need a minimum of 2 rays. Okay, so we got the minimum of 2 rays. Okay, but they don't seem to intersect. They don't seem to intersect as they move backward. So what can we do to get the point of reflection? Like, any ideas, guys? It doesn't seem to be, they don't seem to be intersecting. So what we can do, we can trace them backward, because once we start tracing them backward, it does look like there is a possibility of intersection. So wherever they intersect, that is going to be the image. That is going to be the image. So we have found the image. We have located the image. Of course, I have not drawn this figure by making measurements of distances and angles, and therefore this is not the right drawing, but it's a good thing for us that this is not the right drawing, because it will allow us to not make assumptions. I'll be proving few things, and then we are going to use whatever we deduce from the proofs. Now guys, if I have just simply retraced this line backward, and if this angle is alpha, then I hope you will agree with me that this angle will also be alpha, because these 2 are going to become the alternate angles. Okay, so if this is alpha, this is also becomes alpha, and if this is alpha, again this also becomes alpha. Okay, similarly, if this is alpha, then this also becomes alpha. Okay, so there are many angles which are alpha in the figure right now. I have marked some of them. You can check whether you agree with me or not. You should do that. Alright, always remember that the best way to understand the math done by others is to do the math yourself and then match the result. If it matches, you don't need to see the math of other. If it doesn't match, then you can go step by step and you can figure out at which step you are getting a different equation and the other person got a different equation. That will help you to either identify a mistake that you committed or another mistake that the person committed. Okay, so that is the way to check the mathematical steps, whether you are reading a text, whether you are reading any book, or whether you are trying to understand the theory presented by a teacher. So when there are mathematical steps involved, what you have to do is you have to do the math yourself and then check whether your results match with the teacher's result or not. So here I will urge you to try to find out these angles yourself and see, or try to find out all angles that are alpha in this figure, and then you can check whether you and I mark the same angles as alpha or not. Okay, right now let me assure you that whatever I've done here is correct. Okay, now also pay attention to this fact that this angle will be 90 degree, yes or no? Okay, this angle will be 90 degree, even this angle will be 90 degree. Okay, and this side is common. So in these 2 triangles, which 2 triangle? Let's call this as O, let's call this point as X, where the first ray was incident on the mirror. Let's say this is ray Y, this is point Y, where the second ray was incident on the mirror. So I can see that triangle OXY, okay, triangle OXY is congruent with triangle. It is congruent with triangle IXY. See this triangle OXY is congruent with triangle by which property? By angle side property. Okay, like one side is common and two angles are equal. So these triangles need to be congruent. Okay, which means, which now means that the distance OX will be same as distance IX. Okay, which means that, so we can now declare, or we can now conclude that the distance of object from the mirror, the perpendicular distance of the object from the mirror and the perpendicular distance of the image from the mirror, they are same. They don't look same in my figure, but they are same. Okay, and not only that, you can see that OXI, OXI is a straight line. Okay, is a straight line. Okay, and not only that, it is perpendicular, and it is perpendicular to mirror. So we can say that the image is formed on the perpendicular that we drop from object on the mirror. Okay, so these are two very important points that you have to remember. Okay, so if I want to conclude, okay, so first, the object distance and the image distance from the mirror is same. Second, image lies on the perpendicular dropped from object on the mirror. Okay, and a third point that you can see is that in this figure, object is real and the image is virtual, or you can make a rule that the image formed by plane mirror, it will have opposite nature as compared to the object. So O and I, okay, will have opposite nature. Okay, and this is for plane mirrors, I'm saying. Okay, this is for plane mirrors, not for any other mirror. Like this is for plane mirrors. So these are the things that you have to keep in mind. Okay, now whether you have understood this or not, okay, will this also work in the curved mirror? So Chandradeep, this is only for plane mirror. Okay, now for curved mirror, the formula would be different. Okay, now let me test whether you have understood what I am trying to say or not. And how do I do that? So for that, let me draw a mirror. Okay, or let me do one thing. Let me draw a smaller mirror. So let's say this is a mirror. Okay, and there's one more thing that we can probably try, and that is that if you would have chosen any other ray, you would still get the same, keep this in mind that you might have chosen any other ray. This ray after reflection would also have passed from this point. So you see that the location of this point is not dependent on angle alpha, which means we could have chosen any other ray and we would have still obtained the same image. Okay, so now think about this. Suppose an object is kept here. This is the mirror. Okay, and let's say this is point A. Okay, this is point B, and somewhere here is point C. Out of these 3 points, which point do you think is the best representation of the image? Like, which can be the image? Like, which is the best representation of the image out of these 3 points? Try to give an answer to this question, everyone. I'm waiting for you guys to respond. So, out of these 3 points, which point do you think is the best representation of the image of O? Any answers? I'll wait for some time. If I see any response in the chat. Out of these 3 points, I'll get out of the frame so that you can look at the question. So this is the mirror, that is the object. Okay, this is the reflecting side of the mirror. Okay, out of these 3 points, which do you think is closest to the image? Now, just in case if you are wondering that A or B should be the correct, Shabdullah, C is correct, because generally if you think that okay, we have to draw a straight line from object to the mirror and extend it, and therefore A should be the answer, that is wrong. because this line is not perpendicular to the mirror. You have to drop a perpendicular to the mirror. Okay, and then if you say that, okay, maybe from here we should draw, so no, this is not a straight line then. Okay, this is not a straight line. Okay, this is not a straight line, so no, even this is wrong. Now if you say that, how do I drop the perpendicular then? So guys, what you can do, you can extend the mirror, even if it is given only in this much portion. Okay, you can imagine it to be present here also. You can imagine it, you know, suppose if the mirror would have been here, suppose if the mirror would have been here, then it would have been very easy for us to locate the image. You would have dropped the perpendicular, you would have extended it, and you would have reached somewhere here. All right, and whatever this distance was, let's say d0, at the same distance you would have obtained the image. Okay, but you will ask, sir, the mirror was not present here, how did you extend it? Okay, now if this part is confusing you, okay, so let me justify that by assuming that the mirror was a larger. Let's say the mirror was larger. In that case, the rays would be going like this. You know, I will draw some of the incident rays. So these are some of the incident rays. Okay, these are some of the incident rays. And then after reflection, they will all appear to be coming from the image. Okay, so these are going to form the reflected rays. Okay, these are the reflected rays now. Okay, these are the reflected rays. Oh, this one is wrong. Okay, these are the reflected rays. Okay, now think about this, guys. Okay, think about this. If I remove this portion of the mirror, these rays stay unaffected, like nothing changes for these rays. The angle of incidence is same. Okay, so they should, you know, these rays will not change their course. Or so basically, if you have the small sized mirror, just that the rays that you could have drawn, you get lesser option to draw the ray, but otherwise see, you still get the intersection point at the same. So are you getting it? If the mirror is larger, you get to draw more reflected ray. If the mirror is smaller, you get to draw less number of reflected ray. But it doesn't change the fact that you will still get the image at the same point where you would get if the mirror would have been larger. Or alternatively, what I'm trying to say is that a small part of a small plane mirror will also behave like it will continue to behave as a large plane mirror as far as the location of the image is concerned. Like a small section of a mirror is as good as a large mirror as far as the location of the image is concerned. Okay, now this may seem surprising to you, that how is that possible that a small mirror is as good as a large mirror? Like there should be some difference now. So yes, there is a difference. Now the difference doesn't lie in the location of the image. We still get the image at the same location in both the cases. The difference lies in the fact that how large is the field of view. What is the field of view now? Okay, what is field of view? So guys, field of view is the region in which you can get the reflected ray. For example, in this diagram, if you ask me that, you know, this seems to be the region where reflected rays are heading. So if a person is looking from here, you know, if a person eyes, like if I am looking from here, then reflected rays will enter my eye. Okay, reflected rays will enter my eye, and therefore I will be able to see the image. Okay, but if a person, in this case, you know, in this case, if a person is trying to look from, just a minute, I'll just complete the figure. Let's say if a person has his eyes somewhere here, okay, then the person is not receiving any reflected rays, and therefore this observer, let's call this as observer 1, okay, and let's call this as observer 2. Observer 2 will not be able to see the image. So the condition to see the image is that the reflected rays should enter the eye. So when you use a smaller mirror, you end up getting a smaller field of view. Okay, this region is called field of view. So you end up getting a smaller field of view. In case your mirror would have been large, then reflected rays would have been present here also, like some rays would strike here, okay, and like this, and then they would get reflected, okay. So the field of view would increase. So larger plane mirror will give you larger field of view, smaller plane mirror will give you a smaller field of view, but the location of the image for the two will be same. I hope this point is clear to everyone. I hope this point is clear to everyone. Okay, and now if this point is clear, then let's talk about next point that we have to discuss is image of extended object. See, what we have discussed right now is the image of a point object. So next we are going to talk about image of extended object. Okay, now what is an extended object? So anything other than a point. Okay, anything other than a point. So let's say I said that this is my object, this is my, this is the shape of my object, and I want to talk about the image of this object, the image that will be formed in a plane mirror like this. Okay, so what you have to do, you have to work point wise. What do I mean by that? So identify few points on this object. So let's call this as point A, let's call this as point B, let's call this as point C. Okay, so let's just work with 3 points for now. Now each point of an extended object will behave as an independent point object. Very, very important line. Please note it down. If you are watching this session, this is a key point. This is a key statement that you need to remember, that every point of an extended object, it behaves like a point object in itself. So this point is giving out rays like this, it is giving out rays like this. These rays are getting reflected by the mirror, and therefore the image of A is getting created somewhere here, the same distance. Okay, so let's call it as A prime. Okay, similarly the point B is acting as an independent point object, giving out rays in all the direction, and these rays are incident on the mirror, they are getting reflected, and then we are forming the image of B somewhere, we are getting the image of B somewhere. Similarly C is acting like a point object in independent, like it has got nothing to do with A and B, it is giving out in own light. So every point of an extended object behaves like a point source itself, and C will form its image somewhere here. Okay, and like this, if we can talk about all other points, so all other points will give us their respective images, they will give us respective images, and if you just, if you choose large number of points, you will end up getting an image like this. Are you getting this or not? Okay, so when we have to talk about an extended object, we consider it as a collection of large number of point object, and each point object will form its own image. So the large collection of objects creates a large collection of image, and therefore we get the same shape. Are you getting it? Okay, so this is how we get the image of an extended object. And if you observe something from here, like our object shape, okay, just our object shape was this and our image shape is this, because you notice that the point which was nearer to the mirror, for example A was nearer to the mirror, so its image will also be nearer to the mirror. So we can say that it gets flipped, laterally inverted. If this is the object, then this will be the image. Okay, so it gets laterally inverted. Okay, getting it? Okay, so just to highlight the shape thing, can you tell me that if this is a mirror, okay, and a P-shaped object, an object in the shape of alphabet P is kept in front of the mirror, then out of these options, which shape represents the correct shape of image? So is this going to be the shape of image, or is it going to be this, or is it going to be this, or is it going to be okay, A, B, C, D? Which shape do you think is the right one that represents the image of this object? Which shape is the right one? Correct, Chandradeep. So B option is the correct one here. B option. And now guys, if you have noticed this, can we say that the size of the image and the size of the object is same? The size of, see, earlier we wrote some conclusions. I'll go back to that. Earlier we wrote some conclusion here. So we said that the distance of object and the distance of image is same. Okay. Then we talked about that if image lies on image lies on the perpendicular drop from the object on the mirror. Okay. O and I will be opposite. Now we can add a fourth point here, which is related to size. Why did I not talk about size earlier? Because points don't have any size. We were dealing with point object when we were on this page. Okay, now that we have talked about an extended object, we can add another property here, that size of image is same as size of object. And there is one thing to keep in mind, that these are the properties of image formed by plane mirror. So these are properties of image formed by plane mirror. All right. Okay. So now just to test you, let me ask you guys a very simple question. Okay. So this is going to be your test, or you can say a checkpoint to see whether you have understood the concept or not, or whatever I was trying to teach you, whether you have understood that or not. Okay. Simple question. I'm going to ask. So this is a plane mirror. Okay. This is a plane mirror, and this is a straight line, and on this straight line there is an insect I, or let's say A, and this insect is moving at a speed of 2 meters per second, and let's say this angle is 60 degrees. Okay. I want you to talk about the speed of the image. Can, like, when or what is the trajectory, or what is the path where the image will move, and what will, so you know, if the object is moving on this straight line, or this is the path of the object, let's think about the image of this path. So can I say that the image of this path, will be a straight line like this, making an angle of 60 degrees like this? Can we say that? Like, I'm not drawing the image of insect, I'm drawing the image of path. This was the path, the track on which object is supposed to move. So this is the image of the track. Now when the object is here, the image will be here. When the object reaches here, the image will reach here. When the object reaches here, the image reach here. So can we say that whatever distance the object is covering here, in the same time the image is covering here, so the speed of the image will also be 2 meters per second, and it will also make 60 degrees with the perpendicular dropped on the mirror. Got this, everyone? Okay. So I hope you understood this part. So guys, these were the properties of the images formed by the plane mirror. In next session, I am going to take care of the curved mirrors. That means we are going to talk about spherical mirror, the concave mirror, the convex mirror. So that is what we are going to discuss in our next session. Right now, we have covered plane mirror. Revise this topic and try out some questions also. Alright, I'll see you next week, everyone. Take care. Bye-bye. Bye, Shabdullah. Bye, Chandradeep. Bye, everyone.